Irodov problem number 1.3. A car starts moving rectilinearly, first with acceleration w. The initial velocity is equal to 0, then uniformly, and finally decelerating at the same rate w comes to a stop. The total time of motion equals tau. The average velocity during that time is equal to whatever is given here. How long does the car move uniformly? Okay, so for this problem, let us start with a velocity time graph. Okay, let us say this is the velocity axis and this is the time axis. Okay, what the problem says is this body accelerates with the acceleration w, so the slope of this line is w for some period, and then there is a uniform motion, so it's a straight line parallel to the time axis, and then it decelerates with the same deceleration w. Okay, and it is said that the total time of this journey is tau. Now, if the acceleration and deceleration are same, then can we say the time of acceleration, this time, and the time of deceleration, this time, is same, because it starts with zero velocity, goes up to a certain velocity, and same rate it decelerates. So from that velocity it decelerates to zero velocity. Okay, so these two times must be same. Let's say this is t1, t1. What we have to find is this t, for how long the body was in uniform velocity. The initial velocity is 0, acceleration is given, and average velocity is given. This is 5 meter per second, this is 72 kilometer per hour. 5 meter per second square. Okay, so again, mean velocity or average velocity, the definition of that is total distance divided by total time. Okay, now what is the distance covered in the journey from O to, let's say, t1, t1 plus t, and this is total is tau. Okay, so what is the distance covered in this period? Now the distance covered in this period is the area under the velocity time graph, so area of this particular triangle. So if we know the velocity at t1, then it's easy to find out what is the velocity at t1. It is wt1. Okay, so the area of this one will be half wt1 times t1, or half wt1 square. Now you could have also reached this from the equation of motion for uniform acceleration case. This is a uniform acceleration case where the equation is s equals ut plus half at square. In this case, initial velocity is 0, or half wt square. That's exactly what we have done here. Okay. Now t1 and this t1 are same. So 2t1 plus t, this t is equal to tau. So we can also write t1 as tau minus t divided by 2. So let's substitute that here and find out the total distance in the first t1 seconds. So the total distance in the first t1 seconds would be half w t1 square, which is tau minus t by 2 square. Okay. Now let's find out the distance covered in this interval from t1 to t1 plus t, because this time is t. Now it's looking at this graph, it's again the area of this rectangle here. Or you could have also looked at this equation. In this part of the journey, acceleration is 0, so it is u times t, which is wt1 times t. Okay. So let's write that down. So wt1, now t1 is tau minus t divided by 2 times t. Okay. And then the area of this triangle, again this is now the deceleration case, so it would be the same as this. So what we can do is we can just double this, okay, divided by total time is tau. Okay, now let's simplify this. 2 gets cancelled. We can write this as w tau minus t square by 4. Let's bring the 4 down in the denominator. So this one will be 2w tau minus t times t. Okay, our goal is to find t. So we can bring many of these terms this side. 4 tau mean velocity divided by w. So we brought that w down here. So now this becomes tau square minus 2t tau plus t square, and this becomes 2t tau minus 2t square. So this term and this term gets cancelled out. So this becomes 4 tau mean velocity divided by w, tau square plus t square minus t square. So minus, or we can say t square is tau square minus 4 tau v by w. If I take tau square common, 1 minus 4 v by tau w. So therefore t is equal to tau square root of 1 minus 4 mean velocity by tau w. Okay. Now all is remaining is to substitute these values. So I'm not going to do that, but make sure that your units are all same, so that you have to convert the kilometer per hour to meter per second, and then it should be pretty easy to get to that answer. Okay.